We are looking at section 2.3, starting with the problem 4 from the 2.3 WebAssign homework. In this problem, we're asked to find f prime of x and f prime of c. So the context of this section comes with some trig derivatives, and there's really two main trig derivatives that you'll want to commit to memory. The rest of them you can derive if needed, and you are required to remember a decent number of them, but I would say the two that I would just recommend to any calc student to certainly have committed to memory are going to be the derivative of the sine function. And so the derivative of the sine of x with respect to x is going to be equal to cosine of x. And then the derivative of the cosine function. So the derivative of cosine of x with respect to x is going to be equal to negative sine x. And again, that was proven in an earlier chapter, so you can accept it to be true. Those are the two. You can certainly memorize more of them. And if you're going to be doing these often and using these often, definitely memorize more. But those are the two that I think if you were stranded on a desert island, you only need those two derivatives and then the quotient rules and things like that. I think you could derive the rest of them. So then here we want to find the derivative, and then we'll evaluate the derivative at a point. So we are differentiating a function that is a quotient of two functions that we know the derivative of. So I like to use the Hi-Ho rule. So then we have f prime of x, and you don't have to use this mnemonic device. You can use whatever method you want, but I use the Ho d high. See, the derivative of the sine function is going to be cosine of x minus high, which in this case is sine of x, times d Ho. The derivative of x with respect to x is 1, all together over Ho, which is going to be x squared. From there, we can reduce this. We have x cosine of x minus sine of x over x squared. We could reduce it further. We can't cancel out the x and the x squared because x is not a factor of both terms in the numerator, but we could split it up into two rational expressions and then cancel out one of the x's. I'm going to leave it, but just know that that's something that you could do depending on how you like your answer to look. But let's go ahead then and evaluate this function at pi over 3. So then I substitute in pi over 3 for x. And then we need to simplify and evaluate different parts. So I like to use the unit circle to evaluate trig functions. If you have that committed to memory, that's great. I don't require you to have it committed to memory. You are allowed to use it on tests in my class, but that's kind of up to you. And we are looking at cosine of 1/3. So I have my unit circle, or cosine of pi over 3, excuse me, next to me. I like to have my unit circle next to me. So for pi over 3, we're looking at 1/2 for cosine. And then for sine, we're looking at the square root of 3 divided by 2. And then that denominator doesn't simplify. And again, depending on if you reduce that x or something, you might have a slightly different looking function. From here, you can simplify if you want. You get pi over 6 minus square root 3 over 2 over pi squared, and then over 9. And then to reduce this further, because I don't like complex fractions, I don't like fractions in the numerator of an already fraction, I'm going to multiply, well, let's see, we could multiply by a 9 or a 6. I'm going to just choose to multiply numerator and denominator by 18. We'll distribute that to both terms. In the denominator, this is just kind of more aesthetics. What is your preference for how it looks? So just note that there's multiple ways to do this. And so then we have for this first term, we're going to have 3 pi. And then when we multiply by 18, we're going to get 9, square root 3. And then we're going to have 2 pi squared in that denominator. And then I would leave it at that because it's not asked to, approximate to a certain number of digits. So that's kind of suggesting it doesn't want the answer given to be as a decimal.